Let's imagine something unbelievable for a moment. What if every photo you've ever taken, every book ever written, every song ever recorded, and every cat video ever uploaded could fit into something smaller than a grain of rice? Welcome to the future of memory. DNA-based data storage. It's not science fiction. It's science fact. And it's going to blow your mind. So, what is DNA data storage? DNA, as in the stuff that makes you, is nature's original hard drive. It's been storing the instructions for life on Earth for billions of years. But now, scientists are using it to store digital information, like your photos, documents, videos, and even entire websites, inside synthetic DNA made in a lab. Here's the magic trick. Your files made of zeros and ones are translated into a sequence of A, T, C, and G, which are the building blocks of DNA. That sequence is then chemically synthesized into real DNA molecules. Those molecules are stored in a tiny test tube, not a server rack. Later, scientists read the DNA, reverse the process, and bring your original file back to life. It's a mix of biology and computer science, and it's jaw-droppingly powerful. How much can DNA store? Let's talk numbers. 1 gram of DNA, that's about the size of a pinch of salt, can store 215 petabytes of data. That's 215 million gigabytes. For context, that's 100 million full-length movies, the contents of all major libraries, thousands of times, or every embarrassing social media post ever made, with plenty of room left for more. Compared to today's tech, it's a space-saving monster. 1 gram of DNA can store 215 million gigabytes. That's more than 200,000 times what a 1 terabyte SSD can hold. So instead of needing a building-sized data center, you could literally back up the entire internet in a shoebox, or less. How long does it last? This is where DNA really flexes. Your SSD, good for 5 to 15 years. Magnetic tapes, maybe 30 years. Blu-rays and optical discs, tops at 100 years. DNA stored in a cool, dry place, it can last thousands of years. We've recovered readable DNA from bones and fossils over 700,000 years old. That's like finding a working USB drive from the Ice Age. So for long-term archiving, DNA doesn't just win, it obliterates the competition. Is it more secure? In many ways, yes. DNA storage is physically secure. You can't plug it into a laptop. You need a lab-grade sequencing tech to even read it. It's offline by default. That makes it immune to viruses, hacking, or ransomware. It's stealthy, a tiny tube of clear liquid holding millions of files. Good luck stealing that from a shelf. But here's the catch. Once you decode the DNA, the data is just regular zeros and ones again. So if you want it encrypted, you have to add encryption just like any other file. Bottom line, it's vastly more secure against physical and digital threats, but it still needs software-level security for privacy. What's the catch? Let's not get ahead of ourselves. Right now, DNA data storage has some pretty big hurdles. It's slow, Writing and reading data in DNA isn't instant. It takes hours, not milliseconds. It's expensive. Creating and sequencing synthetic DNA isn't cheap, yet. It's not meant for everyday use. You won't be opening your vacation pics from a DNA stick anytime soon. But researchers are working hard on speeding things up and cutting costs. Big names like Microsoft, Twist Bioscience, and even DARPA are all investing heavily in this tech. Why should you care? Because the data apocalypse is real. We're producing data at an insane rate. Videos, sensors, apps, AI models. By 2030, we'll need hundreds of zettabytes of storage, and traditional methods just can't keep up. DNA offers a scalable, green, long-term solution. No power-hungry server farms. No hardware upgrades every 5 years. No plastic waste or landfills full of dead drives. Just pure, dense, efficient storage, inspired by nature. Imagine storing your entire family history in a tiny DNA capsule. Imagine preserving humanity's knowledge on the moon in case Earth gets wiped out. Imagine digital immortality written into life's own language. Final thought. We've stored stories in cave paintings, in books, in hard drives. Now we're storing them in our most ancient code, DNA. It's not just cool science, it's the future of memory. It's compact, it's powerful, it's durable. 1 gram of DNA can store 215 million gigabytes. That's more than 200,000 times what a 1 terabyte SSD can hold. And it might just be the safest place for humanity's most precious data. Stay safe, stay secure, and the next time someone tells you your data is in the cloud, you tell them the real cloud is biological, and it might fit in a teardrop. Thanks for tuning in. Now go hit that subscribe button and stay curious, my friends.